Yes.
Oh, it's very good. Yes, this is the thing you're talking about?
Yes.
Cycling
Yes.
research board?
Hmm.
Cycling research, amazing.
Yeah. They are very welcoming community. So I was there 2 or 3 years ago in Amsterdam, and Louis was also there a year later, I
Oh,
think. And they're open to all kinds of approaches, also data driven.
that's great. Because some of our students also are really interested in this kind of
Hmm.
data-driven approaches. And yeah, and so I suggest that we slowly start. And
Start. Yes.
if you want, you can already try to share your screen.
Okay.
And great, some people are joining from Cree actually.
Oh my
So
God. Yes, very good. Hello, everyone.
students
Hi.
from Mark, yes. And so
So.
it's really big pleasure for us with Mark to introduce Mikael to you, whose code many of us were forking, but I didn't see a person who
Oh.
actually creating these libraries or like creating these beautiful images and analysis. So it's really my big pleasure to introduce Mikael, who is also co-founder of Nerds at Copenhagen,
Exactly.
and who works on different topics, including bicycles. And floor is yours.
Hmm. Okay, thank you. So do you see the big screen of the
Yes.
presentation?
Yeah.
Okay, great. So yeah, I'm going to talk about two topics, but before I do that, so of course, thank you for the invitation and for this opportunity to talk with like-minded people like you. I just want to say maybe 1 minute about myself, because not everyone knows me, and where I'm coming from, and why I'm doing what I'm doing. So so my background is from mathematics, and I have a PhD, I think, in physics. And what I was doing during my PhD is basically network science. So I studied social networks, and network science is naturally a very interdisciplinary field, because the tools that we develop and that we use can be applied to all kinds of applications and problems, not just social networks, but you can imagine that the nodes in a network can also be street intersections, and the links in a network could be social relations, or they could be streets between the street intersections. And so because of this, it's quite a natural topic. So yeah, and after I finished my PhD working on social network analysis, I moved to the US, to Boston, where I also met Mark Santolini, who you saw before. And I started more a bit of a tech approach, let's say, into human mobility. So that was at MIT, at Sensible City Lab. And maybe my biggest contribution there was this paper on taxi shareability, of how to most efficiently share taxi fleets, basically. But also Boston was the place where I started cycling to work, for the simple reason that it was just the fastest way to move in a city, especially in Boston, where I didn't want to have a car. And also the bus has to share the road with cars, so the bus system is very slow. So I used the bicycle.
And the train system is even worse.
Sorry, where?
And the train system is even worse.
Yeah, of course, yeah. So, and I noticed quite quickly that, the bike system is pretty terrible in Boston, at least. And I was wondering, how is it possible that, this country can shoot people to the moon decades ago, but it cannot build safe bicycle infrastructure. So I started getting more interested in a more, let's say, human-centric approach, in where the goal is to build or to develop cities for people, and not necessarily for cars, for example. So now I'm following really at ITU in Copenhagen this kind of human-centric approach, using tools from network science or data science. So that's the quick summary of where I'm coming from. And here I want to now present you two research projects. And both of them are very new. So the first one that I will talk about, we just finished 3 weeks ago. So that one is finished, and I need to submit to a journal basically tomorrow. And the second one is ongoing research. All right, so the first one is about identifying urban features for vulnerable road user safety in Europe. So this is the title of the paper, which was done together with Marina Hliancic, Letizia Gomez, and Michele Tizzoni from EASY Foundation in Turin. And Marina was basically the, let's say, the student member of this project who we supervised, and she did a great job, especially in acquiring a lot of data sets, analyzing the data sets. So this was quite a tough job, and she had 1 year time for this, and we are very happy with the results, which I'm going to show you now in a moment. So the big problem from which we were starting in the beginning was that every year on the planet, there are 1.35 million people dying on the road. So this is a huge issue for humanity. And this number is actually increasing over time. So currently we are at 1.3, or yeah, in the year 2015, 16, we were at 1.35 million per year. And okay, this is a big issue, and it's such a big issue that the UN in its General Assembly in 2015 said that, okay, we should set a goal, like a sustainability goal of halving the number of global deaths and injuries from road traffic accidents by 2020. And yeah, by the way, you probably know, or many of you know maybe, that also in this assembly, they came up with in total 17 sustainability goals that became kind of a target for the year 2030 in general. Okay, and this 0.3.6 was about halving global deaths. And unfortunately, this was just a goal, but not really a solution, because the global levels of global deaths stayed almost exactly the same until 2020. So now we are in 2021, and we are still at basically the same numbers. Okay, so the question is, okay, I don't know why this happened, but, or yeah, there are reasons why this happened. But basically, there are not strong political incentives, and it's not just enough to set a goal. You also need some kind of bold policy making to change things globally. But you can drill down on in the question of who is dying and why are they dying. So who is getting killed on the road and why? And the WHO makes some observations that it's mostly vulnerable road users who are impacted by this problem. So vulnerable road users would be pedestrians, cyclists, and motorcyclists. And so how could you study maybe with more numbers what is going on? And this is where we got inspired a bit for our project by this very nice project by these two Dutch people, by a journalist and a professor, who were using data sets. They gathered data sets of this kind of reports of who has been killing whom basically on the road. And they found that, yeah, most deaths and most injuries are due to cars, and they are impacting vulnerable road users most. So we can say that the big culprit in road accidents is the car. And yeah, it's because our cities are planned in a car-centric way. So the priority is on cars, and they are also quite deadly. And this kind of matrix that they created is also called casualty matrix. So this is a known term in the field. And actually, the OECD itself recommends to analyze more of these casualty matrices, to collect data on this, to understand better what we can do in terms of policy making to reduce road deaths, especially of vulnerable road users. And the OECD also recommends we should collect data from many cities and also investigate relationships between urban shape, modal share, and road risks. So all of these things, we said, okay, let's do it. So we have 1 year of time, and let's do it. So actually, this is the streamlined version. We had for several months not a great idea what we should do, but then we found out that this would be a nice way to move forward. So basically, I'm showing you now a slide that stands for like 8 months of sweat and tears, especially for Marina, who was writing to all kinds of city councils in the world, in Europe, to departments of transport, to ask for data sets that are also fine-grained enough for this kind of study. And so basically, after 8 months of a lot of data gathering and data cleaning, we ended up with a data set, or with several data sets from 24 European cities scattered around 5 countries. So yeah, and most of these cities are located in the UK and in France. And from all of these cities, we have a quite complete data set that is also granular enough to study these casualty matrices. And so the first thing we looked at, we just plotted all of these casualty matrices for all of the cities, and we found quite some differences. I mean, we always found that, so here, maybe I just explain these plots. So what this means is that, so these are the absolute numbers of killed or seriously injured people, of road participants on the left, and they are being injured or killed by the road participants on the bottom. And the arrow means on the bottom left means that it was like a self injury, so it was just one car involved or one cyclist involved. And what we can see is that the car column is always quite dark. So this is confirming what the Dutch people found in the Netherlands, that the car is responsible for most of the killings. But there are some interesting regional differences also. So London, for example, is especially bad for pedestrians and for cyclists, and also for powered two-wheelers, while Barcelona is especially bad for the powered two-wheelers. And in Rome, there are not many people cycling, so there are not many cyclists being killed, but still it's quite bad for, yeah, for powered two-wheelers. So we see quite some heterogeneity in different places. And also we can look not just at the absolute numbers, but of course at the normalized numbers per, for example, 1 million inhabitants of that place. And when we look at that, then mostly the UK cities are leading in terms of deadliness. So Sheffield, for example, here you can see is pretty bad in terms of car-on-car casualties, while let's say Nice in France and Marseille, they are the worst cities in terms of cars killing powered two-wheelers. And Oslo on the very bottom is the best city, and they reached vision zero, meaning like 0 deaths on the road in like 2 years ago. So Oslo is pretty good. So there's also, you can see there's also quite some heterogeneity in the types of how people are killed when you normalize these numbers. So this was one part of the data sets that we collected. And then we also wanted to look at these kind of urban indicators. And maybe we can try to predict these casualty numbers by looking at the urban indicators. So that was the idea behind the urban indicators. And here we collected from OpenStreetMap, which is this kind of crowdsourced mapping platform. So it's like Wikipedia for maps, basically. We were using this nice OSM&X package in Python to download data about, for example, cycling share. So this says how long are the protected bicycle tracks in a city compared to the length of the streets. And we also looked at the share of speed limited streets. So what is the fraction of streets that have a speed limit less or equal than 30 kilometers per hour or 20 miles per hour? So these are the two urban indicators from OpenStreetMap. And then we also downloaded all the modal shares of the different transport modes from this European platform on mobility management. So modal share is, if the modal share of whatever cycling is 20%, it means that 20% of the people in a city are commuting, let's say, by bicycle every day. But the definitions actually can be different from country to country. There is no international standard of how to define modal share. And so that's why I want to have this very clear huge grain of salt that our analysis here can be at most as good as the data quality. And the data quality can be pretty bad. So I already said modal share definitions can be different, but then also some crashes can be biased in the reporting. So cycling crashes are often not reported to the police. OpenStreetMap might have some data issues, especially maybe for cycling. And there are all kinds of different national data collection standards for how you define a severe injury, for example. So is it, yeah, so here's a small table actually of just some European countries and all the different standards that they are using. So take all of these results with a grain of salt. We can only be as good as the quality of the underlying data. But given that, so we built a statistical model using lasso regression. So this is the only equation that I'm showing you. This is basically the definition of this procedure. It's basically a regression model that, that tries to find the right variables to best predict to make the best possible prediction. And the predictors here were, again, these 5 variables: cycling area share, speed limited share, and modal share of walking, of cycling, and of public transport. And the modal share of cars is implicitly included because it's 1 minus the sum of the other 3 mode shares. Okay, and we built this tool, this regression tool, and we found that our model predicts reasonably well the observations. So in these scatter plots, each point stands for one of the cities, one of the 24 cities. And on the y-axis, you see the predicted values, and on the x-axis, the reported values. And if the dots fall on this diagonal line, then it would be perfect prediction. And yeah, I mean, we of course don't have perfect prediction, but we are predicting reasonably well. And this works for all the combinations of car on pedestrian, on cyclists, and then cars, but it didn't work for the powered two-wheelers for some reason.
Miguel, there is a question in the chat.
Yeah, sure.
If you want to read it.
Yeah.
So
wait.
OSM is indeed crowdsourced. So how did you make sure that the item you were searching for was not there, or but not captured? Did you
So we didn't make sure of that actually, and this is a very good thing to further look into. But there are a lot of because this is a huge effort actually to I mean, there are all kinds of research projects that try to understand how accurate is OpenStreetMap data. And there are several publications that state that in Western countries, at least, like the ones that we are looking at, the accuracy is pretty good. So we have basically 100% of the existing infrastructure covered in OpenStreetMap, but there are always fluctuations, of course. So yeah. And there can also be cultural differences in how in different places people work differently with OpenStreetMap. So I completely acknowledge that one has to account for this, but we didn't do this in this research because it's just a huge effort.
Thanks.
Yeah, great question. So, okay, and the big conclusion of this paper then was, okay, so this predictor, we let the predictor select the statistical model let selects the predictors, and we found that the statistically significant predictors, they were all about, so they are the black boxes here with the black borders. They were all about the modal share of walking. So if you have more walking, then the city is safer for pedestrians, but also for cyclists and also for car occupants. So this was maybe a bit surprising. While the speed limited streets, they were significant, at least only for the self injuries for cars. So this was the result, basically the big conclusion, that cities that have a bigger share of walking are safer cities for all traffic participants. Yeah, so so much about the first project, and I'm happy to answer questions. Maybe also afterwards, we can go back to the slides. Yeah.
The potential mechanism is that the more walking areas you have, the less you use any of the other things you could interact with. So the potential number of interactions is smaller. Because here you don't have a normalizer, it's by the actual number of observed potential interactions, right?
Yeah, so we don't have what is called exposure data. So we don't know how many people are actually walking, how many miles or how many kilometers are being cycled. So this is also a big limitation of this study, that we don't have this data, but it's very hard to get accurate data about this for many different places. Yeah. So we all of these statements or observations are about correlations, and we cannot make any causal claims. Basically, we don't have any mechanistic model that we would love to have, that okay, because of this that happens. So we just don't have that here.
But I looked at the code, I mean, at the repository which you shared, which is pretty impressive that you have this data on the 24 cities, right?
Okay.
And like it's really impressive that you did also.
Okay. Thank you. Yeah, I mean, all of that was done by Marina. That was really all her work. She worked very well on that. Yeah.
I wanted to ask a question also on the scatter plot, and but it's my eyes are doing data science, so it's going to be a stupid question. But it did look to me that you did have some under predictability at high reported car casualty or high casualty in general. You seem to always be under the line.
Yes.
True? Is there a saturation effect, and do you have a explanation for the non?
Yes, there was this weird effect that we also discussed, because there were some outliers somehow, but we don't understand well why they are outliers. We cannot make any causal claims again. But I think London was usually an outlier, maybe, and so yeah, I don't remember exactly. But yeah.
And you didn't include any extensive variable. It's all shares. You don't have a total size or something like that could, because I had the gut feeling that the more people you have, the more opportunities you have to self-report in OSM, and so there might be a nonlinear effect of the population size or things like that.
No, I think the population size that was accounted for implicitly. So I can't give you the technical details, but I'm pretty sure we accounted for that. Yeah.
Okay.
By the model itself.
Okay.
Yeah. Okay. So great questions. Thank you. All right. So then I move to the next topic, which is ongoing research. So I can talk not so much about very detailed results, because I'm basically in the analysis phase of trying to understand all the results. But I can give you the main ideas and the motivation background, and yeah. So and this I called here Towards the Science of Bicycle Network Design. Okay, so it's a bit a bold statement. So this project started with a previous paper that we published in December with Luis, Guillermo Natera Orozco, and Federico Battistone and Gerardo Niguez. That the title was Data-Driven Strategies for Optimal Bicycle Network Growth. And what we did here is, again, we downloaded data from OpenStreetMap. And here, by the way, are two references about how accurate OpenStreetMap is and how complete it is here on the bottom, if you're interested. And we looked at the different transport network layers in each city. So we looked at here, for example, Copenhagen on top and London on the bottom. And each city has a pedestrian network, has a cycling network, a rail network, a street network. And we just made very basic network measures in the beginning. And we found that the bicycle networks are highly fragmented. So they are split into hundreds of components. And I don't have time to discuss these two plots in detail, but basically what the red long lines say is that there are hundreds of disconnected components. So basically London is like, if you would take a nice complete, let's say, spider web and throw it in a blender, and then you get out thousands of pieces, that's what's happening in London. So that's how London looks like. And Copenhagen is much more complete, but still there are 300 disconnected components in Copenhagen. And okay, after we saw that, we focused on these bicycle networks, and we were asking, how should we connect the components? And we came up with a bunch of strategies of how we could do that in a systematic way. For example, largest to the closest disconnected component, or all kinds of other strategies. And what we found is that, so one of the findings was, which is this orange circle on top, for example, about Copenhagen, that if you have a city where you have already a well-developed bicycle network, then it makes a lot of sense to invest just a little bit, but with the right strategy to connect the pieces, and you have a lot of benefits from that. While for cities like London that are very have a very big area and also a very disconnected network, even large investments don't make a lot of sense if you just want to connect components. So basically, connecting disconnected components works in well-developed cities, but in less well-developed cities, it often does not work. So basically what it means, for most cities, it makes more sense to start from scratch. So to just forget all the bicycle pieces that are there and just start from scratch instead of trying to connect all of these tiny little things, because the connections themselves will be longer than the pieces that you started with. And also there is another reason why it's not enough to just connect components, because when you connect components, you end up with something that you have, like here on the left side, this MST, which stands for minimum spanning tree. So you have components that are the nodes here, and they are connected just by one link. So if there is some roadworks and the link is interrupted, then again, you just have disconnected pieces. So that would be the investor's optimum, to just build as little as possible bicycle paths. That's the left side. And the traveler's optimum would be on the right side, where everything is connected with each other. But of course, those are way too many connections than you need. So maybe the good solution is somewhere in between the minimum spanning tree and the fully connected network. And okay, so this is then an idea one can explore further. So this is one of the things that we are currently exploring. So this notion of efficiency or redundancy or resilience, that you add more links than just the minimum number of links needed to have a connected network. And also, yeah, we look at different growth processes. Can you see the animations now? I hope so. Yeah. Okay. So on the left, yeah. So we look at growth processes from scratch, basically, and also at, for example, how much of the area can be covered by a network that is growing in space. And the basic idea is that, so we start with one city. So by the way, we are considering 62 cities that you can see on the bottom left currently. And here I'm just showing Copenhagen. So just imagine Copenhagen had no bicycle infrastructure at all, and you would need to start from scratch. Then what we're doing here is we take on the left a set of points of interest, which in this case, they are just the metro and railway stations. Then we build a so-called greedy triangulation on top of that, which is in the middle, and then we are routing it on the street network. And the order of how we place the links in this animation is determined by some growth metric, which can be whatever you want. And this growth metric then tells you how to prioritize the links. So if I have a limited budget and I can only go to the middle of this animation, then okay, that's what I end up in the end. And we can analyze all of this growth with network science tools and measures. Okay, and one of the big insights here, which is not really a surprise for network scientists, but it might be surprising to urban planners, I don't know, is that we find this kind of percolation thresholds because we are growing networks following some specific strategy, or even if we grow them randomly, there are results from the 50s, basically from graph theory. These are a classical result that you will have a percolation threshold. So you will have the emergence of a giant component where things work quite well. And you have this kind of sudden emergence. So until then, you're losing money by investing into the bicycle network. But once you have this giant component, then you are benefiting a lot from adding more parts to the network. So here is an example of Boston. And where you can see that you start in the left with one small component, then it branches out in the middle, it becomes more or less a tree. And on the right, we already have a giant component with cycles inside. And these cycles are important for the network to be useful for cyclists so that you can be, for example, direct in your route. And I don't want to show you any more details about the results because I'm still analyzing them. But the two fundamental implications on this result is that we need to grow with the right strategy, first of all, but also we need to invest boldly to reach a critical mass. So, and that we can also show that most cities that we study, they are not there yet. So they have randomly put pieces on the map, but these pieces, they don't interact yet. They don't form a useful bicycle network yet. While in places like Copenhagen, we are already there. We have reached a critical mass where adding more parts makes the network more useful. So there's this critical mass in building bicycle networks. This is maybe the big conclusion here. And it's interesting if you study the leading manuals for designing bicycle networks, because they usually say that you should grow networks slowly and make local refinements. And there's a good reason for that. I mean, these manuals are super good. By reading these manuals, I'm learning so much. So this is great. And the reason why they suggest this kind of local or slow growth is because basically of political inertia. It takes, so for example, here you can see the development of Copenhagen's bicycle network, and it took many, many decades to arrive at the point where you can say you have a cohesive network. So it makes sense that the manuals also say you should grow slowly, or that in theory, in practice, you grow slowly. So the question is, can we even plan for a whole city? And so that's not so much for me to answer. I'm not the politician or the one who interacts with the politicians. But what I know is that time is running out, basically. If we don't act fast, then, you know, there's climate change and things are going bad quickly. So we kind of are forced to be fast, to grow these networks fast. And there is some rays of hope. So there is these all kinds of COVID pop-up lanes that show up in all kinds of cities around the world. Some of them are becoming permanent. So there is some evidence that accelerated growth of bicycle networks is possible. And also in Denmark, we have now a big funding strategy to expand bicycle networks. So there is hope that we can find a fast enough transitions to sustainable transport. Okay, so with that, that was my last slide. I just want to say, so just to summarize, my goal is with this kind of nerds group here in Copenhagen is to establish this kind of human-centric data science for urban studies. So I want to combine network and data science and data visualization also to make cities better places. And we are always very happy to collaborate or to exchange ourselves with like-minded groups like you in Paris. And yeah, so thank you for the attention.
Thank you, Mikael.
Oh, thank you. Yes.
So
you know, it's funny. Yeah, go for it.
no. What is funny?
No, because you know, I was thinking all along when you talk about costs for cities to do that. I wonder if people have estimated the benefit of having healthier people and lowering the cost on the healthcare system that you have by doing so. In a way, like the return of investment that you get, basically.
Yeah. There are these cost-benefit analysis that show. So one of them is done for Europe, and it shows that. Oh, I don't have the exact numbers, but hundreds of, is it millions or billions? I don't know, of euros, probably millions more are lost by having car-centric cities. And if you would build more bicycle infrastructure, then society would actually benefit if you consider the healthcare system also, that people are not in this sedentary lifestyle.
Yeah, I hear the same about trees, right? That basically by growing trees, you invest first because they don't become big trees all of a sudden, but at the same time, in 20 years, like your children will benefit from that. And it's interesting. I don't know, like actually here also there were some Strielka people from this urban architecture group in Moscow, which is recent one. And I know that those people there also were interested in, I mean, I was interested as well, actually, in asking you also if you know about who is working on soft mobility, because recently all around the globe, people started to use this kind of scooters, right? And how this influences bikes. Because in Paris, for example, they are dangerous because they kind of are shifting between the bike tracks and car track. They cross car roads like as if they would be unkillable, and like it's very wild. What do you know about the soft mobility data? And
I don't know about much of the research on this kind of scooters, but I mean I can just talk also from experience that a few years ago, you know, there were these scooter sharing companies, and they dumped all of their scooters everywhere, but then many cities started banning them, also Copenhagen. But in principle, I mean, if this were not operated by those shady companies, but let's say if the city would provide public scooters, I wouldn't have any problem with them. I mean, but there is some research on that, but I'm not so well informed about it.
Because it seems that it's something which is kind of almost like fights between these different groups. Like when you analyze bike, for example, providers, data from one provider and another provider, often they actually put their bicycles in the same areas, right? And it's actually strange, right? You would expect that they would have more market if they would kind of share, but in fact, it's not the case, I guess.
Yeah. I know that there is a lot of research on bike sharing, but not that much yet. Maybe on scooters. There was a question here.
Maybe
I can read it.
You can unmute yourself. Yeah.
It's okay. I have a question regarding the growth model of the bicycle network. How do you choose a road to be cyclable? Do you take only roads with speed smaller than 30, or roads that are somehow large enough to host cycle paths as possible candidates? Yeah, so these are great questions. For now, we completely ignore the speed limits and the width of the streets. For now, this is very much a very crude study and more statistical. So So the idea is more to forget about the details and look at the big picture. But this will be obviously the next step to go down in the details and to consider speed limits and widths and where can one actually build a bicycle lane or maybe a shared street. So this is really just the first approach, like the kind of statistical, very crude approach that looks at the whole system. And we need to follow this approach if we want to study a large number of cities also, because otherwise we have to go into the details with every single city, and that's just too much work. So there are these two perspectives. Most perspectives in urban planning, they look at one place, of course, and try to understand all the details of that place, all the historic details, and then there's the other perspective, which is what I'm doing here in this project, that I don't care so much about the place itself, but more about the geometry in general. But in the end, the geometry can be the big geometric issues, they can be applicable to all of the cities. Yeah.
So actually, I had a question about the model because it looks impressive, the graph process you have, but because it's a greedy process, I wanted to ask you a bit about the kind of optimum you're going for, and if you know how far, like if you did some Monte Carlo on it or whatever, to know how far you're from a final solution.
Yeah, good question. So the greedy triangulation is an approximation to the minimum weight triangulation, which is the optimum. So the minimum weight triangulation is that you have that all the connections, the total sum of the connections is minimal, and that you have a triangulation. And the greedy triangulation, but the minimum weight triangulation is an NP hard or NP complete problem. I don't know, meaning it's computationally hard. And running the greedy triangulation is computationally much easier. And you can, there is a proof from like 15 years ago, I think, that shows that the greedy triangulation comes, I don't know how close to the optimum. And yeah, you can argue with that. So yeah, it's an approximation. It's not the best, but it's close enough, let's say.
No, because it looks very good when you showed the pictures. So.
Yeah, I worked a lot on making the data visualization, right?
Yes.
And how?
But it's also.
Yeah.
Go ahead, Mark.
No, because go for it.
Because I was going to ask actually also, because you said that your student was asking for data from consoles, right, all around Europe, and it was something which probably was tricky because it's kind of human data, but it's something which is usual practice now, right, in European cities to share the data about this. Like which cities were the hardest to get the data, for example?
It should be, yeah. The hardest, I mean, there is, it's hard to say hardest because you could write to a place and they could not answer you, then that's hard. Okay. But then it's maybe easier if they have the data online, but it's in their local language. And we covered like 4 or 5 languages in Europe, but not all of them. So and we just had to make a point where we say, okay, we stop collecting data and we don't go further and try to get more, and we start with the analysis. So yeah, so for the UK and France, this data was available online without asking anyone, I believe. And then in Norway, we had to ask, and then they were very cooperative. Yeah, and also Barcelona and Madrid, they worked fine. But I don't know exactly which countries did not work, which were really hard. So Marina knows all of this because she was engaged with it. Yeah. And some places just don't have the data or don't have it where they could give it to you. Yeah.
Right. Anybody else in the audience who wants to shoot out in the chat?
Yeah, actually, maybe another question I had, or while people are thinking, because Claire, who is also here in the audience, I mean, the person who is working on the city growth network, right? And like in general, right, cities were designed so that people would walk in the streets, right? Then afterwards appeared cars. But could you imagine, or do you know any projects where people would design bicycle cities, like cities where only bicycles would be allowed, and what these cities could look like? Because that would be a dream, of course. Maybe you
there
know.
are some of these cities in the Netherlands, for example, and also parts of cities in places in Europe. So I know in Vienna, because I lived there for several years. There is, I believe, Seestadt, or I don't know, some new parts of Vienna where they design places without car parking, basically. And also, like the newest IKEA store in Vienna was without car parking, because you should just go in, say what you want, and then it's delivered to your place. So yeah, there are these efforts, and yeah, I think they're very good efforts, because in Europe we have dense enough built structure that we don't really need cars, unless of course there are special cases like disabled people and so on, where it's good to have cars. But for most cities, you don't need cars in a dense enough city.
Yes, Claire.
Yeah, so there is one place in the Netherlands, I forgot the name, but there are even videos on YouTube about it. I can try to send you later.
Yes,
if I remember the
that
name.
would be nice, because I mean, when you see the evolution of cities like that, they kind of always assume that there would be, I mean, like big transportational like need of building built streets, but not for bicycles. But
yeah, in Germany there is also at least one city, Freistadt, something like that, that is mostly built for bicycles and for walking. Yeah. So there are some places.
It becomes a complex problem, right? Because you don't have the seed hubs anymore. If you think about, like right now, you're seeding with some kind of like predefined local hubs that have been predefined from the growth before. So now you would need to co-evolve these things. Like that would be a hard one.
Yeah. So thinking about coevolution of networks is also a step ahead.
Yes, because also what I remember from Luis, that some people, when you, for example, implemented the algorithm of understanding how their network would need to grow or what is the most optimal, the next stage maybe would be to go to the council or like to the mairie of the city. But your experience personally with that structures, did you try yourself to connect to?
Yes. So in Copenhagen, I'm talking with the Danish Cyclist Federation, and also they're in close contact, of course, with the city, and they're super interested in for example, finding the missing links. That is something that we did also a bit with Luis, how to connect the pieces. They're super interested in that, and they also told us that the city planners, there's so much that they don't know, that they don't even know that they don't know. Okay,
that's a big problem.
That if we show them what is possible, then it might be very good for planning. So we are in contact with them, and they're very interested.
All right.
Well,
should we next phase?
Yeah, I guess if there are no final questions, thanks again, Luis. We were talking about Luis. Thanks again, Michael. And I think that, some of the papers, they already are on archive, right? I mean, you put them somewhere.
The first one is on SOC archive, and the second one is not out yet.
Yes. Okay, then we will wait. And thanks again for your time, for sharing.
Yeah, thank you for inviting me.
Research. Good luck for your research. And
Thank
thanks
you.
again, everyone, for coming in these times. It's really good to see live faces. Yes.
Yeah.
Of
And
people.
Liba, do we stay in the Zoom? Do we stay here or?
We can go to the next one. I think it's easiest, I guess. But yeah.
Okay.
Thanks again, everyone. And
Okay.
thanks everyone
Bye-bye.
for joining, Paul, Claire, and Anne, Michaela, everyone. Bye bye.